Hi class, this is Professor Smith. I'm going to be doing a movie on domain and range of a graph of a quadratic function. In this example, the graph of the quadratic function has a vertex 2, -1, as shown in the figure below. Find the domain. So we have this vertex at 2, -1, and a parabola that opens downward. When they ask us to find the domain, they're asking us to find the x values that corresponds to every ordered pair on the graph. Oh, I got it in. All right. So I'm going to take a look at this first ordered pair, which is 2, -1, because that's the vertex. The x value of the ordered pair 2, -1 is 2. And so I can see that that is going to give me that point right there. So x equal to 2. And then if I project the next one, this ordered pair here, it'll project with the x value of 3. And this one will project with an x value of 4. And in fact, I can even project every point in between 3 and 4. And I'm going to get every single x value in between 3 and 4. The same is also true when I go over onto the left-hand side. So as I project every point onto the x-axis, that's really giving me the x values, which is really the domain. Even though the graph is only shown a portion of it because the y values only go from -12 to 12, if the graph were to go off this grid that's on the screen, you can see that there's also going to be x values for values even further out than the 4 that I have in the 6. In fact, the x values are going to go out as far as the graph goes down. And so we can see that our x values are going to take on everything on the x-axis. And that means it's going to take on every real number. And so if it takes on every real number, we have a special way of representing that using interval notation. Everything to the left, that means it's going as far to the left as possible. We call that decreasing without bound, and that's represented by -infinity. And everything to the right is represented by positive infinity. Because infinity and -infinity are not numbers, we use parentheses to represent that they're increasing and decreasing without bound. So when we say the domain is all real numbers, then we know that's the same as saying from -infinity to infinity. Now we're going to do the same thing for the y value, the range, but instead of projecting onto the x-axis with the red lines, we're going to now project onto the y-axis, and we're going to use a different color. So let's use pink. So now we're going to project our ordered pairs that are on the curve and project them onto the y-axis. In fact, let's use a different color. Let's use green. So that ordered pair that is corresponding to -6, pardon me, 5 looks like 10. That is going to have a y value of 10. Pardon me, -10. And similarly, when I take the next y value on the graph, it's going to correspond to -8. I think that's -8. That might be -7. I mean, -10. I mean, 11. The graph numbers are being hidden. All right. Yeah. So that was -7. That was -8. This ordered pair is going to have a y value that corresponds to -7. So will this one. And in fact, if I take the left-hand branch of the parabola, it's also, because of the symmetry, is going to have another ordered pair that has a corresponding y value of -7. And this will have a corresponding y value of -8. A y value of -9, and a y value of -10. So when we smash all of these ordered pairs onto the y-axis, we can see that we are going to get every value on the y-axis, except for when I get to the vertex here. Those are supposed to be horizontal lines, but my little tool is acting a little persnickety and the lines are kind of tilting upward. But when I get to the vertex, which is 2, -1, it has a y value of -1. So I know that my y values are going to go to top out at -1. So they're going to get the biggest the y values are going to be is here at -1, and then everything below. So all my y values are going to be everything below. And of course, because the graph extends even further, it's going to go on forever. So the way that we represent going down forever is by using -infinity. And then the highest it will be is -1, and that's why the -1 is on the right. So then the question then becomes, is it going to be an open parentheses at -1 or a closed bracket? Well, since the vertex 2, -1 is actually a point on the graph, i.e. it satisfies the equation, we want to include that point. So therefore we want to include the y value. So we want to include that -1, which make this a bracket. So therefore the range is going to be from -infinity to -1. So we'll go ahead and put in our answers. So we're going to have -infinity. Oh, I forgot the parenthesis. Comma, infinity. And then for the range, it's going to go from -infinity. I keep forgetting the parenthesis first. Comma, -1. And since that's a bracket, I'm just using the keyboard to type in the bracket. And there's the bracket. So I hope this movie on domain and range of a quadratic function was helpful.